All right. Hi, everyone, and thank you for joining me in this session where we will explore the fusion of strategic planning with the precision and thoroughness of automation, showcasing the symbiotic relationship between the two. Specifically, I'm going to share with you part of an attack process map for enumerating and attacking public domains in a thorough and consistent manner, while highlighting the benefits and the difficulties of applying layers of automation. There are plenty of guides, mind maps, resources, generally speaking, on the internet, and certifications, of course, that demonstrate how to approach and exploit a target in a detailed and structured manner. However, for security testers that wish to be the best they can, a well-studied and maintained documented approach is a must. Think about it this way. If while testing, we all use approximately the same methodology, toolsets, and resources, then the best one is either the fastest one or the luckiest one. Not to mention that we won't be able to emulate real-world adversaries, which is the goal in security testing. We all think in a slightly different manner, some of us even in extraordinary ways. It is important to consume and digest all these resources and labs out there available for everyone and structure that information in a way efficient for our own way of thinking. With that said, let's move to the enumeration and attack plan we're going to work with and showcase a few practical examples of strategic planning, creative thinking, and ways to efficiently apply custom automation. Here on the left side, we see a typical penetration testing process infographic. If you Google search the string penetration testing process, you will see hundreds of similar high-level infographics. On the right side, we see the same thing, but in a much more detailed version. Today, we're going to focus on these first two stages, passive and active information gathering, and vulnerability assessment and fuzzing and detection, following this more detailed approach. Before we jump in, just let me explain how to read this thing. We have these big gray rectangles that are basically process groups, and inside these process groups, we have in purple boxes, controls and actions we must implement to be thorough with that process. And under these purple boxes, there are specific actions or sometimes tool names, etc. You can see also that each process group has input and output, with the initial input to start this process as a whole being the scope. And HDMI doesn't love me today. Come on, man. Okay, just let's. I'm not a great stand-up comedian. I can't keep your attention for much longer. Come on, have some faith. It's coming. It's OFFENSIVEX. I feel like I'm in the War of the Twin Towers, and I'm waiting for Gandalf to appear on the corner. Oh, yeah, it's there, but it's not up. All right. Okay, the first process group that we see here. Regarding information gathering, data collection, and enumeration will be the basis for everything, as we need to collect some information to work our way in an organization. I'll try to go through this fundamental group and establish the ground for more interesting things to come later on, like the preparation and analysis process that follows right after. A step to analyze, transform, and weaponize the information we collected instead of simply passing them as input to other tools without thinking. And finally, we'll talk a little bit about fuzzing and vulnerability detection. A few ground rules before we jump in. First of all, it's not perfect. I didn't come here to demonstrate the perfect pentest methodology or tell you that you should follow this mind map exactly. Secondly, the grouping you see here also takes into consideration the timeline of actions, meaning when does it make sense to initiate certain processes in parallel, even if they belong to different categories. And lastly, this enumeration and attack plan does not take into consideration attacks that require user interaction, like, for example, phishing, as well as any physical ways to collect info about an organization, like dumpster diving. So let's begin. The first process group, as I said, is the most standard and simple. It includes some pretty basic categories of controls and actions we must implement to be thorough with our passive and active enumeration and data collection. Probably the oldest trick in the book, an attacker will attempt to collect as many third-level domains related to the Apex target domain as possible, and this, of course, can be achieved by enumerating by querying public DNS servers, which will potentially reveal valid subdomains, or maybe a zone transfer would be possible, which is a serious misconfiguration that will basically return a domain zone records back to anyone. And querying public DNS servers, of course, will reveal IP addresses as well, which should also be submitted into reverse DNS enumeration. This sometimes will reveal additional subdomains due to the fact that many DNS records may be pointing to the same IP address. And of course, IPs are subject to port scanning that we all love and know. Another brilliant way to enumerate possible valid subdomains about a domain and find more targets is to enumerate TLS certificates issued by public certification authorities. And just to have an idea, I'm going to show you Microsoft.com TLS certificate. This is the website of Microsoft. We can access it from our browser if we go to the lookup here, connection secure, more information, view certificate. And if you scroll among other info, you see several subdomains. It's not always the case, but it is a must for thorough enumeration. And in the context we are speaking, these for us are targets. And it's very valuable information. Thankfully, there are tools, online tools, that allow us to query bulk data about subdomains related to historically issued certificates. For example, there's cert.sh, which does exactly what we saw, but will query historically created certificates for Microsoft or any domain that we query. For example, Tesla.com, if I do a search here, you will see if it works, because this site is really cool, but it's really unstable also. And we can see that right now that it's taking so long. Also, it's a huge domain. It happens sometimes if you query Tesla.com, Microsoft.com, SpaceX.com, it will take some time to return data. But if you see this column right here, look at the amount of subdomains we collected, and all of these are possible targets for us. There are other websites to do that. I have listed some here, and we'll talk a little bit more about it later. And of course, we can perform subdomain brute force using automation and lists with possible valid subdomains as keywords, which may reveal additional stuff. Moving on to the next category, a beloved one for the pen testing and bug bounty tribe, cached content. One of the most interesting things about the internet, actually, the fact that certain organizations crawl and archive it in various ways. I mean, okay, how else would we have search engines? But there's so much more to it. I've listed some of the internet bots I consider to be the most important for a penetration tester, and I'll just do a super quick run through them. The Internet Archive, or Wayback Machine, a library with a history of billion websites, archiving content since 1996, free for everyone to query and, among other things, retrieve historical versions of websites that can be crawled to discover URLs, paths, file names, parameter names, and values, cached content, generally speaking, which of course is an invaluable enumeration tool. And let's see very quickly how does that look like. I have already done a query. I saved a URL with a predefined query for the Coca-Cola.com website. Okay, and here we can see 39,000 snapshots since December of 1997 of this website. And if you go back here in these calendars, you can visit how this website looked back then. But I think the most juicy here from a hacking perspective is the URL section. These are all cached URLs from years of snapshots of this particular website. And you can see specific files, specific directories, which may or may not still exist, or may be unmapped or hidden, and may include vulnerable components. A similar organization, Common Crawl, archiving the internet on a monthly basis, provides historical data to everyone for free, mainly for research purposes. Common Crawl offers petabytes of data served in segments that can be downloaded and analyzed, or can be crawled, given a URL pattern like a domain name, directly from the Common Crawl index. Luckily, there's plenty of free and open source tools like GAU, spelled G-A-U, that can retrieve certain types of content, like cached URLs from the Wayback Machine archives, Common Crawl archives, and a couple of other cached content providers, something of great importance for thorough enumeration. VirusTotal, the famous internet utility for scanning files and URLs for malicious content, also provides various details and insights about domains cast by the various queries submitted by users, I guess, and is a great resource for discovering additional subdomains. And this one is a bit sneaky, so I'm going to show you how exactly this works. This is the home page of VirusTotal. I'm sure many of you know it. I have also saved a query so that I don't have to type right now for specifically Tesla.com. And if you, here in these tabs, if you go to Relations and you scroll a little bit down, you will see that it caches subdomains. And this content can be retrieved either by just copying it here. There's an export utility, I think. Or there's also an API for VirusTotal, and you can add it to your automation and retrieve additional subdomains, potentially discovering bugs. So then, everyone's beloved search engine for internet-connected devices is yet another must-use platform and API for discovering hosts, subdomains, open port, and service versions, or even verified vulnerabilities. I'm going to take a leap of faith here and say that SODAN does not need introduction. Census, an internet intelligence platform for threat hunting and attack surface management, an invaluable tool to discover company assets and subdomains, provides a very powerful and flexible search utility similar to what we saw already. I left the most common and standard for the end. Search engines like Google can be, of course, utilized to retrieve cached content. And with the power of Google Docs, searching using advanced operators, you can discover subdomains, secrets, or leaked sensitive info, and I'm going to share with you more on that very soon in the leaked content group that follows. There's an incredible GitHub project called Awesome Hacker Search Engines, really great content for anyone interested that wants to take a note. In it, you will find tons of search engines and cached content providers to build upon your tactics and automations. And just look how awesome this repository is. You can find it under this account. And you can see here it has categories of search engines or cached content providers about attack surface code, surveillance cameras, web history, device info, Wi-Fi networks, you name it, certificates also that we saw earlier, you name it, and it has it in there. Leaked content, there's really no end to the type of information that may intentionally or unintentionally get leaked. Database leaks are probably the most common and essential when an application gets compromised, and it happens even to the best ones like Facebook, LinkedIn, Twitter, and the rest. The first thing that the malicious actor will probably attempt is to export data usually stored in a database. More frequently than not, database dumps are made available to the public via torrents and forums, which gives researchers and hackers, of course, I mean the bad guys, the chance to download them and extract information specific to a target domain or individuals to potentially discover credentials, personal data, and so much more. In the awesome hacker search engines we saw a moment ago on GitHub, you can find many online query tools to search leaked content, such as credentials, most of them with a paid subscription, or you can join the dark side and start downloading these leaks and use scripts and command line tools to filter content based on keywords. Except of database dumps, we may find API keys or token leaks within cached content, for example, an authorization token or even credentials present in URL parameter values that have been cached by the Wayback Machine that we saw, or even a search engine like Google. And if you find that unlikely, I will very quickly show you two major findings I had in the past by enumerating targets with those engines. So some time ago, I had this assessment of a very, very big company, a private courier company here in Greece. They gave me some target domains, public domains, and I really like to start my assessments with Google Docs because I can potentially see what is the technology fingerprint of a company. I get an idea of what's going on, what is the security posture and everything. So I started with a very simple Google Doc. I used the site operator and a domain name that is obfuscated here, so that I can limit the results of my search just to this particular domain. And I also excluded everything related to the www domain, which is usually for public consumption, so I don't really care for that so much. And you can see that there's a single result coming back. Okay. Now, this URL, if you visited it back then, it was a cast error message of a CRM that this company was using. And the error message does not really reveal anything interesting, but the URL, if you take a look at it, it has in parameters main ID, main pass, user ID, user pass. And okay, when I saw this, I said, okay, this is obviously credentials. And when you find the key, you're looking for the keyhole, right? So I started trying to find where would that fit. And by just doing a second Google search for this particular subdomain that I discovered with this error, I found the service.asmx file, a file that in ASP.NET applications describes the methods supported by this application. And you can see here it has 5 methods: cancel order, get order checkpoints, get orders, get single order, insert update order. Here's a better picture of that. And if you click in one of these, you will see an example request and body response. And here's what it looked like. And it might remind you a little bit of the URL, because in the parameters of the example request body, you see main ID, main password, user ID, user password, and then the rest of the parameters that you need to do something, right? 15 minutes in the assessment, 2 Google searches, 5 burp requests, and I had the keys to the kingdom. I could send everything that you ordered from this company to me, or cancel your orders, or something like that. It was really cool. Another example, this is from a bug bounty last year. I was searching with the Wayback URLs, this command line tool that you see right here, which basically queries the website we saw, the Web Internet Archive. We saw an example with Coca-Cola about it. I was testing the domain of a company that provides travel packets, like accommodation, tickets, and all of the packets to do some vacation. And I searched for cast URLs, I saved them in a file, and then you see I'm just reading this file, and I'm grabbing with year 2023 because I wanted to see recent content, recent back then. And then I also grab with the keyword last name to see if anything juicy comes up. And there were some URLs returned, you can see here, that in the URL parameters, you can see that there is a last name, okay, and now you can't see anything, and it's gone. There was a last name, there was a first name, Nicole, there was a PNR, this is the passenger name record. There is her email was here, I obfuscated some stuff. Fare, how much she paid, what is the flight number, what is the departure date, the carrier code and everything. Okay, personal data leaked, this could be an issue on its own, but I said to myself, okay, we have personal data. What can I do with this? Like, how can I prove? Because these bug bounty platforms, they need proof, like that you can do something bad. So I started digging this carrier code to see if I can find where this woman made this booking, and I discovered it wasn't hard to discover that it was lot.com. And then it clicked in my mind that maybe the booking reference is this PNR variable that was in the URL. And of course, I had her surname as well. So I could initiate check-in process for this passenger. And of course, I didn't complete to see what an actual malicious actor could do. But this was a valid submission. And all of these little stories were from cast content alone. And it was really fast to trace these vulnerabilities also. Moving on, just let me place this where it should be. Contemporary content, which I define here as the current publicly available and accessible services and information over the internet designed either for public consumption regarding a target domain, present in any form, meaning URLs, text, files, code, social media posts, you name it. It's quite important to collect as many valid URLs and HTTP traffic captures as possible by using web crawlers, automated tools that walk the content of a website and spider every component to discover URLs and other sensitive info. Project Discovery's Katana is a great tool for that. And of course, HTTP proxies like Burp Suite, Kaido, or Z-Attack proxy. This approach allows us to potentially identify vulnerabilities in real time while browsing and crawling. Additionally, it organizes categories, files, and endpoints from requests and responses, enabling us to feed this data into other tools for further analysis. Since most of the applications we find today on the internet utilize APIs a tremendous way to map them and create rogo documentation, if not available, of course, is to use a very cool tool called MITM proxy to Swagger that is basically converting captured HTTP traffic into Swagger documentation, which makes it much easier to study its endpoints characteristics like supported methods, path variables, request body structures, or required headers, and attempt to exploit them, of course. Most of these enumeration processes will often lead to the discovery of cloud endpoints, which is a hacking category on its own and includes a dedicated repertoire of enumeration tactics and attacks. Wrapping up the first process group, we will possibly end up with lists with valid subdomains, IP addresses, open ports, running services, URLs from both cached content and contemporary content, cloud endpoints, captured application traffic, and also maybe even credentials if we have done some leaked content and cached content enumeration. Not all actions in this process group can be automated using a Bash or Python script, but for the greatest part, there's a free and open source tool we can use, not to mention paid services, right? For example, for subdomain enumeration and all of these things that I described, we can use AMAS, we can use DNS enum, sublister, the same for brute forcing subdomains and performing reverse DNS enumeration. We have Nmap that we love, and Nabu, another tool from Project Discovery that we can do port scanning. We have GAU, Wayback URLs, and a bunch of other tools that can help us search for cached content. We can have subscriptions or download leaked content in our archives and just grep it out to find sensitive info. And of course, we can use, for example, Katana, Burp Suite, and all these tools we mentioned for contemporary content. So for the most part, we don't need to reinvent the wheel. There's a bunch of awesome tools out there, new ones popping out every day. We can utilize them to build our own Frankenstein's monster. As you probably figured out, this is not going to be a PowerPoint thing, but I need to show you a couple of slides at this point before we jump into action. So naturally, a tester may try to glue all these pieces together and create the ultimate automation script that he or she will run on the command line, passing a few arguments like a target domain, and it will automatically call a number of tools as background processes, while storing each tool's output in a structured hierarchy of files and folders. Sounds good, doesn't work. At least not in the long run. There are many scripts and tools like that on GitHub, and it's fairly easy to create your own. It's also very useful, and it's something we should have in our toolkit as testers, but it is only a fraction, a first step towards what I'm trying to describe when talking about layers of automation. If you use a solution like that for bug bounty or pen testing, after scanning 20 large domains, you will probably feel like flipping the table. This is mainly because it is quite challenging to navigate through large amounts of data stored in a file system, even if structured and organized efficiently. A truly sufficient approach ideally includes at least the following components. One, it should store data in a database server. A database management system beats a file system in managing data, mainly because database servers use advanced indexing techniques to quickly locate and retrieve data, have better concurrency features, and databases also ensure data integrity through atomicity and isolation. Trust me, it's painful to delete half your file system by running a bash script with a typo, which I have done numerous times. And two, there's no bigger fan of the command line than me, but when talking about repetitive tasks like enumeration routines that as a professional tester or bug bounty hunter you will constantly implement against targets, it will just make your life incredibly easier to have a graphical user interface for navigating through all of this collected data. In a pen testing process, you will eventually have to get your hands dirty anyway, especially in the exploitation and post-exploitation parts. And of course, manual testing. A free and open source platform that is close enough to what I'm describing and you can very quickly install and start with until you build your own solution is Re-Engine. And let me introduce you to this magnificent tool. You can find it on GitHub. Just Google GitHub Re-Engine. Reengine is a platform that can do almost all of the enumeration parts we analyze right now. It offers this magnificent user interface, and it stores everything in a database automatically. So here's how it works. You can go and add your targets in this panel right here. Just you do add targets, and you can put a domain, or you can put an IP address. I have already scanned something that, because I can run really the routines that Reengine supports right now. I have scanned Tesla.com. And after you have submitted a target, you can just use this initiate scan feature here, and it has various types of scans you can use: full scan, OSINT, port scan, subdomain scan. Basically, it covers the stuff that we talked about. And when you're finished, it provides this target summary, a very detailed and nicely organized summary. You can see here, for example, for Tesla.com, it found 791 subdomains. It also discovered some endpoints. Even 2 vulnerabilities here are reported. This has some awesome graphics. You can see where these IPs and hosts are distributed. And it will just make your life much easier until you build your own automation. And I will explain why I insist on that later on. Also, Reengine supports multiple users, so you can have many users that your colleagues or friends, and maybe you have a common target, so you can just all log in and handle your targets from there. And after you have collected some targets, for example, I can go to the subdomains tab here and say, okay, this inside.tesla.com looks interesting. What are the IP addresses? I see them here. What is the response code, a typical response code from the web service running there? It's that. I can initiate other routines on top of that. In further scan subdomain, there are routines to choose: subdomain discovery, port scan, OSINT, dirfuzz, screenshot. You can have a screenshot of this thing, whatever it is. And it's really, really easy to install and start using it immediately. Back to our plan, we enter the second process group where things finally start to get interesting. Having collected as many subdomains, URLs, and IP addresses related to our target as possible, it is the best time to initiate certain second-stage enumeration routines, including but not limited to scanning all these subdomains, URLs, and open ports, if we haven't already, in order to identify web technologies and specific service versions, or crawl of these URLs for sensitive info. We can do that with GoSpider, JS Miner, burp-suite extension, or you can just start grabbing out output of URLs with your own regexes to discover stuff. This is a really great thing to do. You can do some target selection and prioritization. You can, for example, there are automated tools that take as input a list of subdomains, and they will just take a screenshot of all these URLs so you can see what's actually running. When you have 700 subdomains that run web services and you want to see what the hell is going on, if you take just a screenshot of all of them in 5 minutes and then you just go through these pictures, it's just really easy to say, how? That's really interesting, or this is not interesting, I'm not going to attack this, or something like that. And of course, we can analyze captured application traffic. An example was MITM Swagger to proxy that I mentioned earlier. If you save traffic in a file from burp or even your browser, you can use this tool to create Rogo documentation. This line separates the second stage enumeration with the preparation and analysis stage. As I mentioned before, it is a point to take a step back, digest, and also weaponize the information collected so far. From this point onwards, we start to talk about more creative routines, like generating custom word lists tailored for our target. It is a key factor for differentiating ourselves from all other testers and bug bounty hunters out there, and have better findings in general, because during the fuzzing, brute forcing, and sensitive content discovery stage that follows, we will require lists with directories, file names, parameter names, etc. There are, of course, major collections of such lists in open source projects like SecLists, which are awesome, but they're also kind of overused. Just for the record, there are organizations that distribute word lists that are recently compiled and up to date with certain technologies. One of them is AssetNode, and in case you are not aware, just search for AssetNode word lists. I'm just going to show you this very quickly. So this is the page, and you can see some very recently compiled lists of, and they are technology specific, most of them. You can see here JS files, JSP files, PHP, curated list, or with possible parameter names. You have Swagger, generated list from Swagger documentations, I guess, or Django or Flask related specific word lists. We're still missing word lists that include keywords related to our target. A common and effective technique to create custom word lists is to crawl target-related URLs and extract words from text, comments, and symbols in HTML and JavaScript code. The URLs from cached and contemporary content themselves, collected during the enumeration stage, also provide valuable keywords like subdomains, path names, and URL parameter names, which can be reused in different contexts to aid our efforts. Here's a few technical tips for spidering target URLs in order to generate custom word lists. So I have created this stupid little website that we're going to crawl. This website, which is very simple, as I said, includes both static and dynamic parts, meaning, actually, let me show you in the code what I mean. So this is the code of this website. It has this division here, hello there, we saw this message, and then it has a comment, lorem ipsum, something. It has this div with ID Batman and some text, and also has a link to this security.js. And this security.js creates a new header element that has the text content general canopy, and it's dynamically adding this to the page while the page is loading. And the second dynamic part is that this function here grabs the element with ID Batman that we saw and changes the ID value to Spider-Man. Okay, and it's called right here. So you're significantly missing out if you're only crawling the static response of websites. There's a very famous tool called Cool, spelled C-E-W-L, very famous in this domain that crawls URLs, and with regex patterns, it just grabs these keywords and creates a custom word list. But this tool is doing this statically. And let me show you what we're missing out when this happens. I'm going to use now a tool that I am developing. It's not yet free and open source, but it will be soon. I'm just finalizing it, but we can use it for this example here. And I'm going to crawl this page that is running locally on my system. The parameters don't really matter except of this one, only static, which instructs this tool to only just grab the HTML code, what you get when you see a URL, and crawl it. Okay, I'm going to run the tool. It retrieved the static response body of the URL, and here it does an analysis of the words it found. It's not many because it's a tiny website. And you can see some of the words we saw present in this website, but you can see none of the dynamic components. For example, in the IDs, meaning the names of IDs of elements that it just grabbed, you see Batman that we saw in the HTML code, but you do not see Spider-Man, which comes after the page has loaded. And nowadays, web pages are based on dynamic content. They just load at first something, and then it's just bringing data in. And we're significantly missing all the stuff. But you're also missing if you crawl websites only dynamically, because, and let's do that. I'm going to clear. No, I destroyed everything. I'm going to clear out here and use the only dynamic flag. And if I do that now, it's using Python Selenium. It's starting basically a background Chrome process to retrieve this data and like expand the website like it would do if it was loaded in a browser. Now, in the IDs that we gathered, among other words, we see Spider-Man, which is the dynamic changing ID, but we do not see Batman, which is the original static one. So in order to have all of these juicy words, actually what we need to do is scroll both the static and the dynamic part of a website. And if I do that, I'm deleting this flag because the tool will automatically do both. If I do that, I will have both of these dynamic elements. Now in the IDs, we see both Batman and Spider-Man, okay? And also general cannot be was a dynamic part that also was not present at the beginning. But the fun does not end yet because these words that we collect from websites that, it's text among HTML elements or JavaScript functions and stuff like that, it should be processed. It should not be grabbed with a regex and be slapped in a list. It must be processed because sometimes if you really read the HTML code of complex websites, you will see that some values have base64 encoded values or other types of encoded values. Even this stupid little website, it has a custom attribute name here that has a base64 encoded value. Okay, this value, if I decode it, it's the word hasta la vista. Okay, but in the crawling we did, I'm going to do it one more time because I deleted it. This word is not in there because there's no processing occurring. These words are just entered into a list. We don't see, if I do grep dasai, actually better. Hasta la vista output.txt, where this is saved in, it's not there, right? But if I run this again, and this time I add the convert base64 flag, because this tool also is doing this processing of words, you will see that I will end up with a list that will include even these decoded values. And somewhere in here, there must be hasta la vista that I can't really see it right now, so I'm just going to grab it out. Okay, you see that it is in the output list, right? The fun with generating lists is not over yet, because the custom keywords we collected need to be mutated based on what we're fuzzing. Let me give you a simple example. One of the many details that may improve our craft. Let's assume that we are fuzzing a web app for hidden URL parameters. First of all, the existence of a hidden parameter, a parameter that will never appear in the legitimate application traffic generated by users while browsing, suggests that the developer actually coded the functionality of it. Why would the developer do that? One, most likely for debugging reasons. Two, maybe for malicious reasons. How many CVs are based on hard-coded accounts, backdoors in web interfaces? I mean, it's countless. And lastly, perhaps because of misconfigurations or oversights, there are some forgotten, uncontrolled parameters that may introduce security risks. And that we, as testers, we of course need to look for them, right? If someone really implemented secret functionality based on a hidden parameter, he most likely did not name it secret param or X. Especially in the bug bounty world, where the level of web applications you come across is advanced, it is highly unlikely. Assuming that the hidden param name is guessable, we can do some recon to identify common patterns and naming conventions for debug parameters in this example. Don't forget that we have AI chatbots that can chip in valuable information for everything. But most importantly, we can use our own intuition. If I implemented a secret debug parameter in an application, what name would I give it? Let's see a couple of examples of common syntax, possible syntax, for debug or hidden parameters. So I was brainstorming one day. I was looking for ways to improve my craft and everything, and I thought maybe a developer influenced by using programming languages might use special attributes and functions syntax. For example, in Python and other languages, we see function and attribute names into double or single underscores. And I said, okay, if that is a possibility, maybe single ones are also a possibility. I asked also my own intuition. I said, if you really implemented a secret, you want to create a parameter that's hidden, okay, and you don't want people to discover it, what would you do? The first thing that my stupid brain shouted was, just put 5 underscores in front of the name. I mean, who's gonna brute force with 5 underscores in front of the name? Okay, or maybe it's just a keyword, like this param name represents all of the custom keywords we may have collected from a list. Or maybe we just use a list from seclist, and we are producing more words based on these rules that we see here, right? So maybe my intuition or our intuition is correct, and maybe also these patterns exist. We have to also think of the case sensitivity in this area, right? So more or less, you may end up with something like this. And when it comes to creating patterns and word mutations, our best friend is Hashcat, the famous tool for performing password attacks. The rule-based attack engine that Hashcat includes, which is sort of like a programming language designed for keyword-based password candidate generation, can help us mutate words based on custom rules for pretty much anything. We can simply turn these patterns that we see into Hashcat rules, you see it on the next column, and use it in combination with our custom lists, but also common word lists from seclists to generate more realistic word lists and search for hidden URL parameters, significantly raising our chances of actually discovering something interesting. And of course, any type of content we need to fuzz based on word lists can and should be analyzed in this manner. Another very interesting thing you can do here before we go into attacking or fuzzing stage is perform rule-based subdomain permutations to be used in the virtual host discovery stage. And we're talking about the subject. I cannot think of a better tool than AlterX, once again created by Project Discovery. The tool basically takes domains and subdomain strings as input and generates even more possibly valid subdomains based on customizable mutation rules, similar to what we saw with Hashcat. I'm not going to show you the tool because it's super simple to use. Really, it's like you just slap some subdomain strings in it and it just mutates them. But I'm going to show you the configuration file it uses to do that, because it's all the source. Okay. In this file that this tool is reading, and this is just a minimal example, it has this section, payloads. You can see some words, dev, lib, prod. You can see some years. You can add also your own payloads. You can just name it something and just add values. And up here, we see the patterns that the tool will use. And if, for example, our input was client.target.com, based on the rules that we see here, this would also create dev.client.com or, client-dev.target.com or dev, of course, it produces all of these words that we see here, or dev-client.target.com, and it has even more complex stuff here. And if you really pay attention to all of the data that you have enumerated, subdomains, for example, you have collected 1,000 subdomains for a target. It's a very realistic number. Usually it's more than that. You can just read through them and find patterns that these system administrators basically use. If you recognize some patterns, you can just slap them in this and generate even more possible virtual hosts and discover unmapped content, unmapped services that would most likely be vulnerable. Let's go back. Wrapping up our second stage enumeration, preparation, and analysis processes, we merge into the fuzzing and vulnerability detection stage equipped with everything we got from the first enumeration group, plus custom word lists, suitable targets per attack vector, subdomain permutations, intelligence regarding the technologies in use by our target, service versions, sensitive info, and who knows what else. Entering the fuzzing and vulnerability detection stage, and especially if we have been thorough with our enumeration, preparation, and analysis, we will have such a vast amount of testing resources and targets, even for a medium-sized domain, that it will be challenging to cover as much ground as possible during the usually limited time frame of an engagement if we do not utilize carefully crafted automation routines along with manual testing. Additionally, the routines and actions we usually implement from this point after are much more time-consuming and abstract. The main purpose of our actions is no longer to collect and analyze data, but to fuzz using multiple word lists, payload lists, and vulnerability detection templates to discover bugs, CVEs, hidden content, functionality, and anything else that may indicate a vulnerable component. Utilizing publicly available tools, this can be fairly easy. And at this point, I'm going to show you another example with a platform that I have been developing, a prototype actually. So what you see here is called SubRadar. It's not a public tool. It's just a prototype for something I'm building, something like re-engine. It does. It can do everything that re-engine that we saw earlier can do, and what we saw in the first process group. It's just significantly more ugly and stupid. But it allows me, at least, to add my own enumeration routines, because it's not a project that I just downloaded and I'm using. It's something I built from the beginning. It's easier, I think, than it sounds. And let me show you, for example, what it does. Basically, I have this interface that I have this form. I can go and say, hey, I want to scan Tesla.com, and pass some other arguments, like what user agent I want to use, maybe an HTTP proxy, maybe some delay between requests. All of these parameters are standard in bug bounty programs. Bug bounty programs usually have some restrictions, like use a user agent that has this value, or limit your request to 5 per second, or something like this. So this just distributes these arguments into all of the tools that will be in the background called by this interface. I have also a collection of all my targets, for example, here, and I can say, for this code.com, for example, it's a domain that belongs to Coca-Cola from a bug bounty program currently live on Integrity for anyone that wants to play. So I can go here, and I have created a view that works for me. What was I saying at the beginning? Like, we work with the way we think, right? And I rely really in cast content. Cast content has given me many bugs and many findings, and I really like to have this view of everything I have discovered. Here is, for example, 1,000 plus cast URLs. Usually it's 100,000 in bigger domains. Here I have a function that automatically grabs out based on interesting parameter names. I have a live cast URLs, all my subdomains, and I can initiate new routines that I want on a specific data group. Like, for example, maybe I want to turn all of these base URLs all of these subdomains into base URLs, and run Katana to find new subdomains. I just click this, and it will just run Katana, and will start enumerating, doing that from the Wi-Fi of this venue. So I'm gonna stop it right away. But I can also use Lexilog, the tool that we saw earlier, that will create a word list out of all of this. It will just start requesting static and dynamic content, create a word list for me that I can just parse again and again in other routines. And I have even more weird routines. For example, I like to take all of the valid subdomains I have discovered and all of the IPs I have discovered of a target, regardless of if they are mapped with the DNS record, and just try every IP that runs a web service with all of these virtual hosts. Because in the past, I have discovered test versions of web apps or dev versions of web apps in, completely unmapped IPs that were also, though, listed in this DNS enumeration for a target. And it's just something I like to do. A more weird routine. Like, it's not like a tool, you will not find a tool to do that, but you can script it on your own, and if you create something like a framework, you can just go and say, hey, what is this domain? It's code.com, okay. Check for subdomain takeovers, or check this, or check that, okay? Oh, we found one. Damn. I will report that later. The rest of this process group includes stuff like fuzzing for unmapped or hidden content. We talked a little bit about this, vulnerability scanning and password attacks, among other things. I'm not going to go through these action groups extensively. I think the biggest challenge here is scalability. And consider the following, for example. At some point, you are going to have to start fuzzing all of this hosts, right? So if you do a directory brute force to discover hidden directories or files, having done all of this enumeration, this thorough enumeration process that we discussed, okay, wouldn't the number of targets and requests and everything you will have, wouldn't it look like the number of unique services multiplied by the number of virtual hosts that is running in every host, multiplied by every directory that you're going to brute force? You're not going to just brute force the root directory. Multiplied by all of the world lists that you are going to use, multiplied by the extensions that you're going to use, and all of this multiplied by multiple methods that you're going to use. Okay, add to this mix a rate limiting requirement, maybe 5 requests per second, and this will become an impossible task. It will take just way too long. Okay, so in this stage, you need to start building something like orchestrators, something like handlers around tools. For example, if you're using FFAF or GoBuster is your main fuzzing tool, you need a handler that will just call all of this, it will retrieve from your database maybe all of these IPs, all of these web services, all of these visual hosts, all these word lists, and will just orchestrate this whole process. And of course, prioritization of targets can save you time. Filtering word lists will definitely save you time. You could use distributed fuzzing, meaning use some cloud services, rent some machines, or use multiple computers in your house and just send commands to multiple machines to start attacking. But I think the best advice here is start early and keep it running, and have a good handler that will not error out. Closing up this presentation, I hope the benefits of developing and maintaining your own strategies and routines through a collective approach was clear. Unless you study the structure of an existing platform and contribute to it, like Re-Engine that we saw, you'll be limited to what others have built and served. Developing and maintaining your own platform has many benefits. It enhances your understanding of how applications work, making you a better hacker. To make the project even more beneficial, you can choose to build it with new technologies you are not familiar with and expand your knowledge base. A custom framework offers customization and flexibility on the spot, greatly improving your performance as a tester. And you can always share your platform and routine with the wider cybersecurity community, making it open source, which can potentially be great for your project and career. I hope you found this useful. My name is Panagiotis Chartas, aka Telemachus, and it was awesome to be here today and present to you.